Oikein aurinkoista torstai-iltapäivää kaikille ja tervetuloa mukaan tähän Westernacherin ja SAP FINUGin yhteiseen webinaariin. Mun nimi on Alexis Lozada ja toimin SAP FINUGilla toiminnanjohtajana. Ja meillä on tänään mielenkiintoinen agenda SAP IBPn ympärillä ja meillä on täällä pari asiantuntijaa Westernacherilta, Alexis ja Aki, ja annan herrojen esittäytyä tuossa piakkoin tarkemmin ja mennään sitten syvemmin päivän agendaa, mutta käyn tässä aluksi ihan lyhyesti läpi käytännön asiat tästä webinaarista ja tuttuun tapaan sitten pieni kurkkaus tuohon FINUGin tapahtumakalenteriin. Eli te osallistujat olette kaikki äänettömällä mutella, mutta voitte toki osallistua kysymyksiin ja kommentein tuon questions eli kysymykset osion kautta ja tuonne loppupuolelle webinaaria sitten ollaan varattu hieman aikaa teidän kysymysten ja kommenttien läpikäymiseen. Te tuutte myös saamaan nämä esitysmateriaalit jälkikäteen sekä myös tämän tallenteen tästä webinaarista palautekyselyn yhteydessä mahdollisimman pian. Hyvä. Kurkataan tuohon FINUGin tapahtumakalenteriin vielä ennen kuin mennään päivän aiheeseen. Tässä keväällä on tulossa mielenkiintoisia tapahtumia. Tuossa ensimmäisenä 21. päivä eli ensi viikolla tulee tuo SAPin järjestämä SAP ETP Innovation Day, ja tämä on ymmärtääkseni asiakas- eli käyttäjäyrityksille suunnattu tapahtuma, että jos PTP kiinnostaa, niin käykää ilmoittautumassa. Tuo ei ole FINUGin tapahtumakalenterissa, mutta lyhyellä googletuksella löytyy varmasti ilmoittautumislinkki, jos tapahtuma kiinnostaa. Mutta sitten FINUGilta kevään suurin ja kaunein RACE-seminaari, teknologiapainotteinen seminaari Clarion hotellissa 28. päivä tulossa. Lämpimästi tervetuloa. Siellä on aika iso joukko jo tällä hetkellä ilmoittautuneita mukana, lähemmäs 200, mutta vielä mahtuu mukaan, jos haluaa, ja julkaistaan tuossa alkuviikosta ensi viikolla lopullinen agenda, mutta mielenkiintoisia keynoteja ja useampi asiakastarina siellä sitten päivän aikana lavalla, ja totta kai sinne mahtuu upeissa korkeissa tunnelmissa Clarionissa niin vielä pikku afterworkit sinne seminaarin päätteeksi, ja aurinkoa on tietenkin tilattu myös. Jos on golfaaja linjoilla, niin käykääpä ilmoittautumassa tuonne golf-turnaukseen tuossa ennen juhannusta pidetään Keimola Golfissa Vantaalla. Sielläkin aika nopeasti täytty nuo paikat, mutta vielä mahtuu mukaan. Taisi olla 54 se maksimimäärä, ketä mahtuu rangelle sitten pelailemaan, ja ollaan aika isossa määrässä jo tällä hetkellä, mutta nopeammat vielä ehtii mukaan. Lisääkin tulossa, mutta tässä tämänhetkiset tapahtumauutiset, ja hypätään päivän agendaan ja samalla vaihdetaan kieltä englanniksi tässä lennosta. Eli all right, let's get on today's agenda, which is SAP IBP with Westernacher and Alexis and Aki. I will now hand it over to you for today's agenda.
Yes, thanks, Alexi. Good afternoon also from my side to our webinar discussing important business planning topic with direct financial impact, the inventory planning. Yes, my name is Aki Pousar and I'm leading the Westernacher operations here in sunny Helsinki, Finland. I will shortly let our senior architect Alexis to open the topic itself, but before that, just shortly a quick recap who we are at Westernacher. We are a global SAP service provider. We have operations in 21 countries, including Finland, headquarters in Heidelberg, Germany. We've been in the business for 50 years and currently fully dedicated to SAP consulting. Today we are plus 1,000 people, fully own ourselves, and we are carbon zero. I'm very proud of that. Our expertise is in supply chain management that applies to warehousing, transportation, and planning, which is the focus area today. And one more slide, Alexis. Just a quick promotion about our webinars during next weeks, which you might see interesting. Next week, May 23rd, we have a webinar about APO to IBP migration, also hosted by Alexis. On June 6th, we have another webinar provided by FINUG. And this time it's about transportation management and business networks. The registration page opens during the next days. Happy to welcome you there as well. In mid-June, more about planning, especially from the financials point of view, again, financials planning on IBP. So please navigate to westernacher.com for more events and registrations. Yes. Now over to Alexis, let's start to improve the inventory planning. And people online, please post your questions, like Alexis said, on chat. We'll take them at the end of the show in our Q&A. Yes, stage is yours, Alexis. Have fun.
Thank you, Aki, and thank you everyone for attending today's webinar. I'm Alexis Lozada. I'm an associate principal for Westernacher Consulting. I'm located here in the United States, and so it's my privilege to talk to you about inventory planning. And let's start with the most basic fundamental question. Why should I improve my inventory planning, or why should I consider inventory planning to begin with? It's about three factors that we can talk about, and I'm sure there are a lot more. But at a business perspective, it's about driving a sustainable business, sustainable in the financial sense, meaning cash, being able to generate cash, which is, it provides long-term sustainability to your business. It's not the word sustainability that we talk about today in terms of, you know, the impact to the ecosystem, to the earth, but about financial sustainability. Why should you consider improving your inventory planning? It's about unlocking that cash from your operations. And you see a graphical example here of a company where their cash conversion cycles, which measures how many days it takes for you to return cash to your business. If you look at the column there, you'll see that on the right-hand side, you'll see that it takes about 145 days for that company to generate cash from operations. And that's an increase from 138 days in past periods. And you see that in cash conversion cycle, there are three factors that drive that: your accounts payable, your accounts receivables, but your days of inventory outstanding. So you see here that this is a clear example where you have a company that it takes more than 90 days to move inventory. So that's important. If you are able to consider solutions that can lower the number of days of inventory outstanding, that means that you're going to increase the number of days that operation will generate cash. So reason number one, unlocking cash from operations. Why improve inventory planning? If you're holding excess inventory, there are many operational costs that are being driven from it. The most fundamental one is that you're making product that is going obsolete, or because you have excess inventory, you're getting a lot of product that is going to get damaged, physically damaged. That has an impact in your margins. And so here's an example again of the same company where you see that from 2023 to 2024, margins are going down. Is it driven by inventory? Perhaps not, perhaps yes. But what is true is holding excess inventory or unnecessary inventory, drives, it can deplete your profitability in your business. On the other hand, also not allocating inventory in the right place can lead you to move inventory, spend on logistical costs like transportation to move inventory from one of your location to another location. That has a direct impact into your profitability as well. You're basically using an asset to move inventory that will not add value to your business. That's reason number 2. Reason number 3 is in the world of today, where there are so many external and internal disruptions, and this is, kind of the talk of the day, supply chain risks, supply chain disruptions, supply disruptions from vendors and so forth. You need to buffer for uncertainty, to cover for those uncertainties that happen in your business while maintaining your customer service levels. So it's about balancing inventory at the right places, at the right time, right quantity, to buffer for uncertainties while you're protecting service levels to your customers. So here's another graphical example where you have a company that their total inventory allocation is mostly allocated in work in process, very little in finished material. This is not right or wrong because it depends on the industry, it depends on your supply chain strategy, of course, how you balance inventory. But then there are 2 questions that need to be answered. Is this the right balance of inventory according to my supply chain strategy? And should I hold that much inventory too? And so many questions to open, but what is true is about the importance of inventory planning is about balancing the inventory appropriately across your supply chain network, allocated where it matters to meet customer service while buffering for uncertainties. Reason number 3. So hopefully I've given you 3 reasons why considering inventory planning or improving your inventory planning will impact your business. And this is sort of the summary of it. The summary of it is, if you have a comprehensive approach to inventory planning, you will be able to connect the benefits of inventory planning to your business results. So balancing inventory across your supply chain, meeting your customer service levels, lower material obsolescence, minimize warehousing and logistical costs, have a direct impact in your business performance, from freeing up cash from inventory working capital investments, increase your operational margins. And lastly, it's also about building sustainability and resiliency with balanced inventory investments. So we're talking about why is it important, how you can do this. It's all about considering SAP IBP for inventory, the inventory module within SAP IBP, which offers you the opportunity to cover the tactical inventory planning within your planning process. And this is a solution that offers a multi-stage inventory optimization. So it's able to produce inventory plans, including your entire end-to-end supply chain network. So when we say end-to-end supply chain network, we're talking from warehouses receiving raw material, warehousing where you are warehousing finished materials through your manufacturing process or your assembly process, the distribution network of warehouses that delivers to the customer. So end-to-end, that's what, and today I'm going to talk a little bit more about that graphically, but that's the definition of the end-to-end supply chain network. You're able to maximize service levels because this is a solution that consumes your customer service levels as an input to the inventory optimization. It considers all the uncertainties that impact that end-to-end supply chain network, meaning your demand variability, your supply variability, your service variability. And it creates buffers across that end-to-end supply chain network to cover for those 3 variabilities. You can visualize the plan based on networks, and I will show you in a minute. So this is really more focused on making inventory plans per the networks, per individual networks within your business, and I'll show you an example. Lastly, but not least, it's about then elevating the role of inventory planning within your team, where you can have a concerted, consolidated process across many stakeholders. So just to share a little bit, the best practices of the best companies that have established best practices using this solution is they've created a centralized inventory planning team, and they are the ones coordinating the entire process across global operations, local operations, but they become sort of a center of excellence. So organizationally, you need to elevate that inventory planning team. So what? Here's how we build a robust approach to inventory planning with SAP IBP for inventory. There are basically 4 steps in this process that you can control. There are pre-processes that are important to help you with your inventory planning strategy. One of them is segmentation. So the solution can help you define segments of products and prioritize those based on what service level you want to achieve with those products for your customers. It helps you calculate the forecast error, which is the demand variability input into the model. And then a most recent innovation is about the operational supply lead time. Because this is a multi-stage network planning, it considers all the sourcing relationships within that network. Your internal distribution of material, your production or assembly lead time, production lead time, and your vendor sourcing lead time. And it considers not only that lead time, but the lead time variability. Those are 2 key inputs into it. So what's important about this pre-process is that it helps you automate, basically, the process of defining customer service levels based on segments, defining demand variability, and defining lead times and lead time variability. I'll show you examples of that, of the outputs of those 3 pre-process. Once you're done with that, then it starts the day in the life of a planner. So the day of the life of the planner starts with 2 steps. One is for the planner to visualize and understand and make the decisions related to the input assumptions into the model. So this is a solution that, in order to build a robust and have confidence in the plan, the planner has to be aware of the key input variables that are driving the plan. And that planner should be empowered to make decisions regarding that input. One way to empower the planner is scenario planning. So as a planner, you can run simulations and scenarios that run very quickly to understand the impact of changes that you can make to those key input variables. After that, then it's all about reviewing the outputs of the plan. But in this case, the planner should focus on things that are exceptions. So there's a high level of automation here where the planner can just focus on the few materials that she or he deem important to review instead of trying to review every single product, right? There is the ability to do manual overrides, and because the planner should understand that, of course, in cases there are models, the model is not capturing everything. So there is the ability to override. And like I said, you can run what-if scenarios, simulations on the fly or systematically as well. Then, as you finalize from a post-processing perspective, as you're finalizing that safety stock, then the question comes, well, what if I cannot adopt the optimal inventory plan suggested by the solution, by IBP for inventory? Well, I can run a prediction to understand what that service level is, meaning there is a shortage of supply, and I'm not going to be able to produce X amount of optimal inventory. Now it's going to be lower than that. I plan my optimal, let's say at 99% service level, but now I'm going to have to plan a lower safety stock, for example. Well, what will be the impact? I know I'm not going to achieve 99%. You can predict what that service level will be, and I'll show you an example as well. All in all, you'll see that this is a very comprehensive approach. The planner has a lot of empowerment. There is a lot of automation that happens in the background that the planner doesn't have to worry about. But there is a lot of tools available to really end up understanding the impacts of several scenarios, several decisions, including what that service level prediction would be. So with that, there are 3 elements that were introduced recently in this solution, and I already touched points on those, that also contribute to building a robust inventory plan. One is connecting your inventory planning to the operational lead time. So as I said, this is a model that supports consumption of lead time and lead time variability. And typically these are, if you think about from a planning organization, these are inputs that typically don't get reviewed very often. They're basically plugged in and then they just leave it there. But what if you can actually have a more current understanding of what's happening to your operational lead times physically and be able to use that as the input into your inventory plan? That's going to give you a much higher level of confidence that those inventory plans are based on what's actually happening in your physical supply chain. I'll show you examples of that. The second aspect of helping you build robust safety stock is that you have cases where you want to constrain the maximum safety boundaries that you want to hold in your network, whether it's a business strategy, whether it's a regulatory strategy or a regulatory requirement, whether you want to, aggressively move certain inventory from some locations. Now you have the capacity to build those buffers, including optimizing inventory based on those maximum safety boundaries. So there are two choices. One, you can optimize based on customer service level. The other one is you can optimize as a maximum safety boundary. It gives you flexibility and choice, and it doesn't have to be for your overall business. It could be applicable for some networks in your business, some business units in your business, perhaps some product categories as well. And then the third one I already talked about also, which is predicting service levels when there is a need to override your safety stock plans. So what are the key challenges in supply lead time in planning? Well, it is important to jump into why consider supply lead time in planning is because there are unexpected external or internal disruptions of supply. These factors that are happening all the time have an impact in lead time and lead time variability. So this solution allows you to capture what's happening in the latest results of your operational lead time. So an example is, the ship that got stuck in the Red Sea, in the channel, in the Suez Channel, the bridge that the ship that hit that bridge in Baltimore, the pandemic, whatever those events are, even the most menial internal events that might happen to your supply chain, that has an impact in your lead time. There's also a challenge where typically lead time assumptions in planning, and this is not just inventory planning, but planning overall, are disconnected from operational execution. This helps you connect that operational execution to your planning. And at the end, because you're making input lead time assumptions that are closer to your operation, that could help you prevent out of stock positions, help you protect service levels, right? And so here's an example of the typical example of a static lead time input. So your distribution typically assumes a 1 week, for instance, and this is a hub to a spoke model delivering to customers. And then your production lead time ranges between 1 to 4.3 weeks. Some of it is your vendor as well. But if you are to make calculations on dynamic operational lead time inputs, and when I say dynamic, IBP for inventory allows you to recalculate this as often as your data is updated, right? It looks at the past order records. It creates a time series of your transportation, production, and vendor orders, and it's able to capture what's happening in the past horizon, whether that's six months, 12 months, but it helps you calculate what is actually my operational lead time. So if you compare it to the static slide before, right, where your internal distribution was about 1 week, when you calculate that operational lead time for your transportation, you'll see that that assumption of 1 week is actually completely underestimating your inventory plan. You should be planning based on, you know, different lead times across all your downstream locations, right? You'll see that some of them, the lead time could be as high as 2.6 or 3 weeks, right? And you'll see also in your production lead time, you were overestimating in a way your production lead time because it's actually a lot lower than what you were assuming. Again, it brings your lead time assumptions into planning to the reality of your operational execution. Why constrain maximum safety days for inventory planning? Again, strategic or regulatory requirements. You want to buffer to protect flow from supply disruptions. You want to minimize obsolescence or shelf life requirements. That is the use case for considering constraining maximum safety days for inventory planning. And then the last but not least, predicting service levels. Again, unexpected external disruptions are going to cut your supply. You're going to have to plan for a lower inventory number. What's that impact to your safety, to your service levels, to your customer service levels? If there are manufacturing shutdowns, maintenance schedules, local holidays, or even if there are financial requirements that a CFO comes down, a director of finance says, we need to lower our inventory exposure financially, come back with an answer. This is another tool for you to come and say, okay, yeah, if we lower this, we can meet this financial requirement for inventory. However, this will impact my customer by X amount of points. Now you can make smarter decisions. You can provide exposure to the risks of, you know, making those financial requirements decisions. So having said that, I've given you a lot of theory so far, but let's show you a quick demo on SAP IBP. So today I'm going to use the tool called Manage Analytic Stories. It's the latest analytics capability within SAP IBP. I built a flow for inventory, and you can see that I have basically created a flow where it covers the pre-process steps that I referred to. It covers the inventory analysis, and it covers the post-processing step, which is approval, finalizing your safety stock plan. So you can see here that there are built-in blocks in the pre-process step. One is I have actual customer service level, target service level per ABC code. So as a result of my segmentation, now I have segmented my materials for A, B, and C. But then when I compare it to my actual customer service level, I have for A items, my actual service level is 99. My target should be 99 as default. But then when you see B and C, I'm actually achieving service levels that are higher than the segment. So I should be planning for a much lower service level because these are lower segment products or materials. So it helps you, segmentation, it helps you build a different type of service level strategy. And perhaps because you're considering B items and C items, you're treating them the same way as A items. Perhaps you're building inventory in excess or more than you actually need. So this is part of one of those key pre-process, and this is more really on the strategic side to really how to plan, how to define my service levels per segment. The second one here is I see a heat map between finished goods and locations that deliver to customers. And so I see what my coefficient of variation of the forecast error is. This is basically the demand variability. My demand variability could be 0, could be excess of 1, but for most cases here, I have a medium variability in my materials. So a coefficient of 0.4 is actually medium variability. A coefficient higher than 1 is really high variability. Why is this important? The higher this value is, the higher the safety stock you're going to have to build to buffer for the higher demand variability. So it is important to analyze across my finished materials and the locations that deliver that, what is that demand variability assumption? Last but not least, I have transportation and production, but I'm going to simplify this. because this is my total business. A planner is not going to look at the entire supply chain network. IBP for inventory breaks down all the different networks that were optimized together. So here in this filter, I have what I call the IO network ID. This is produced by the solution. And I have, because I know my demo, I have 2 distribution networks. These are networks that, buy, purchase from vendors and distributes to the customer. And I have about 6 manufacturing networks. I buy raw material, I process it, make it into a finished good, distribute it to the customer. So let's say I'm at the planner and I'm going to focus on my manufacturing _0 network. And that really narrows down what I'm going to focus on. You can see that this is actually a 1 material network. And then this is a material that is a B material. So when I ran my planning, I use a 97 service level instead of 99. You see that across my locations, this material has medium variability. And then when I come here, I start comparing what is my transportation lead time assumption across lanes, which is 1 week. But then my supply lead time capabilities within IBP allows me to understand what is the average, the average lead time that I'm capturing in the latest operational execution, which is about 1.9 weeks. I have a minimum, a lower limit, which is 1.8. I have an upper limit, which is 2. So on average, I should be planning for this lane, right? From this location to this location, my lead time assumption should be 1.8 weeks, not 1. So you see now the power of this supply lead time solution within IBP. Same fashion for my production or vendor. So you'll see that I have a manufacturing location here where I'm assuming in my plan, in my baseline plan, I assume that it takes 1 week of lead time to make this product. But then I'm averaging 1.8 weeks instead. And then also when I look at the suppliers 1 and 5, sourcing to my location in Dallas, which is where I make that product, my assumption was 4 weeks. It should be about 4.8, right? So now you see the logic of the power of the visibility, that now I can capture what's really happening, what is my lead time actually physically compared to what I'm planning in putting it as a baseline assumption. So this is just the lead time, and then in the same fashion for the same lanes, you see also the differences between what I'm assuming as an input, as a variability input versus what is actually the variability operationally. So you see the difference between the blue, I'm assuming a much higher variability than I actually have in my transportation. And the same thing goes into my production, that I'm assuming much higher variability than I'm actually achieving in the operational process. There's a lot of more technical details of how this is arrived, but for now, I just want to show you the power of the operational lead time topic and how it can help you make robust inventory plans. Once I'm done with that pre-process, then I go into my inventory analysis. My inventory analysis is about consuming 2 things. What is the impact of scenarios? What is my plan in the future? How I'm balancing inventory across my network, right? So if I stay on my same manufacturing _0 network, I have 3 scenarios that I'm consuming here. On the left-hand side is my baseline plan. On the center is my plan if I use that operational lead time as an input, right? And then the third one on the far right is my scenario if I put a maximum safety boundaries and I constrain that optimization based on the maximum safety boundaries rather than my service levels. So right out of the bat, the planner can come and say, okay, well, let me see these 3 plans and how I should make those decisions. You see here that there are, of course, this is a B item instead of an 8 item. So my service level will be lower than what I'm actually achieving. You'll see that, for instance, my base plan, I'm making an investment of $200,000 when I should actually make one that is about 23% lower. So that is what the 23% is about. But I know that my lead time assumptions are no closer to the operation. So am I overestimating that saving, right? So you'll see here in the center that if I run my model based on operational lead time, my inventory savings are not as significant as the 23%, but I'm still achieving a reduction of inventory of about 12%. Then if I go and say, okay, well, let me run a scenario where I need to constrain safety, my maximum safety boundaries. The results are somewhat similar to operational lead time, but I just wanted to give you visibility that this is also possible within the solution. But now you see the ranges. Now you see the planner looking at these scenarios, and of course, I'm giving you a high level a view of it, but this is feasible within the tool. They don't have to run the scenarios on the fly. They could, but you can also schedule on what we can call schedule the scenarios. You can schedule the scenarios as you go every time you do a run of the inventory plan and be able to just come in and consume the results. Then you come here to more of, well, how am I balancing my inventory here? And you can look at network-wise, and here's a graph that based on this network ID that I'm focused on, I can look at my end-to-end network, multi-echelon network via what we call echelon IDs. So you'll see here that my last mile distribution to customers is echelon 1, where I make my product is echelon 2, and then where I source is echelon 3. So now you'll see that for this particular product, FG3, you can see how I'm balancing inventory. And I can compare it, in this case, I'm comparing to the cost of what I'm actually physically holding versus my recommended on-hand stock value. So you'll see that the savings are there, that you don't have to hold as much inventory downstream, and you don't have to hold that much inventory upstream either, with one exception. Well, not exception at all. Yeah, one exception here. For this particular material, you actually have to increase your on-hand stock position. Now I have an end-to-end network view of where I need to balance my inventory. You'll see that it's not just about taking inventory across the network and that's it. It's about balancing. And you'll see that, of course, you don't need to hold as much finished good downstream. Also in the second echelon, not as much, but there are some materials where you need to hold more inventory, right? And so again, it's about balancing inventory where it needs to be. The other thing is, of course, this is a time series model. So it is important also to look at what is your future safety. So these are weeks. They don't show but for the next, let's say 52 weeks, what is my recommended safety stock value plan? What is my on-hand stock value plan? So it helps you plan into the future. You can plan this per week, per product, per location into the future. This is just for this particular network, the entire material plan. Of course, you can look at this at the product for each product location combination, what this plan is. I'm just giving you a really high overview. And in fact, you know, if I want to look at a specific product family, what this may be. So let's say product family 1, then I can just look at what that projection is. I think that because this is product family 3, that's why it's not showing, but there you go. There it is. So you'll see now that I have for this network, for this product family, what that projection may be. Last but not least, and then I'll try to move quickly here, run out of time because we have some more stuff to do. One last thing that I think is very powerful in this tool is that it produces a safety stock recommendation, right? So you'll see that there is a recommended safety stock of 73,000 units. Is about averaging about 73, 72,000. into the future weeks. But what's powerful about this tool is that it helps you break down the drivers of that safety stock. So of this, let's say 75,000 units recommended for this week 16, what's really driving that safety stock recommendation? So as I mentioned, the building block for safety stock are driven by three variables, three variability factors. One is the demand, and you'll see that out of the 76 units, about 11,000 is driven by your demand variability. That is no surprise because this is a material that has, medium variability input, demand variability input. Supply variability is actually the biggest driver, and you'll saw that because the lead times are longer, the variability is higher, so it makes sense that supply variability is a big factor in your safety stock positioning. There is a service variability that is very little, so there is very little service variability in the network. Don't have to worry about. Why is this important? Why this visibility is important? Because first of all, it will help your planner understand what are the variables that are really constructing that safety stock. So it gives you more detailed visibility to what that safety stock calculation is. The second aspect why this is important is because if you want to lower your safety stock, now you know where to focus. And where you need to focus is, let me look at lead time, let me look at lead time variability. The good news now is that now you have a tool within IBP for inventory that can help you understand that supply lead time better. And of course, I did this on purpose to bring that up again, but this could look in so many ways. And again, this will vary depending on what material, what location you're looking at. You will see those drivers there. Now, once I'm comfortable with this, then let's go into my finalization, my post-processing step. At the end, the planner is trying to decide what is that safety stock plan that I need to recommend. This high level, of course, a planner will not do it at the location, region, product family level. Typically, this decision is done at the product material level. But what is important about this is the solution recommends a safety stock. You can make adjustment to that safety stock, and then it captures what that final safety stock is, that then you can integrate into your MRP or into your next supply planning phase. So that flexibility is there in the tool. It's already set up that way. But what happens if I need to adopt a number that is lower than that recommended safety stock? Well, before you make an override decision, then you can do a prediction of what that service level impact would be. And here's a graphical example of what this may look like. So the blue bar captures what my baseline plan is for safety stock for this network, right? So it's about 74, 76 into the future. I plan at an average service level of 97%. What if I need to cut down a couple of units to override that? What will that impact be? Well, it helps you. There is a solution within IBP for inventory that will help you predict what that service level impact is. And this is what that line is at the bottom. So from a target plan of 97, if I do override my safety stock plan, and you can see for about 3 units in the next weeks, what is that predicted service level? So it will go down to, you will lose a couple of points of service levels, 95% on average, right? But you can see that this is also changes throughout the time series. So you'll have a time series prediction of that service level impact as you make a decision for a lower safety stock plan. So these are tools, as I mentioned, that will help you build a robust inventory plan. It help the planner make smarter decisions, but also help the planner explain the numbers to management and be able to visualize and bring to light key decisions that now we know how we will impact the business. So with that, let me switch back to, I believe is this, yep, to just to connect to our broader message, right? So why consider a comprehensive approach to inventory planning? The reason is it can help you balance your inventory, meet service level, lower material obsolescence, minimize logistical and warehousing costs. Why is that important? How is that connected to your business performance? It's because it will help you free up cash, increase operational margin, and build that sustainability and resiliency with balanced inventory investments. This is not just theory. There are over hundreds of customers that have adopted this solution, and these are the results that they have seen across the board and across their business. So with that, I just want to say thank you. And on behalf of Aki and myself, thank you and for the privilege of talking to you today. But now I think we can open it up for questions.
Yes, definitely. Wow, thanks, Alexis. How cool is that? As a finance guy, I love to see the financial impact. Yes, and I hope the audience online liked as much. But yes, okay, now time for questions. We have still like 13 minutes. People online, please type your questions in chat and we'll take it from there. And of course, meanwhile, I have some questions of my own, no surprise. Alexis, please explain how long it will take to implement such a thing, typically like standard setup, what would it require? And also maybe explain when the business should start realizing this positive financial impact, your experience.
So thank you for the question. So typically an implementation of IBP for inventory, first of all, it depends on the scope. So the typical scope, so let me explain the scope and then I'll talk about the implementation timeline. The fastest cases that I've seen over the years of implementation are the cases where you start with 4 or 5 product categories and their distribution supply chain. So when I say 4 or 5 categories of product materials or product groups, and then your distribution network is basically from the plant that makes those products to the distribution centers that deliver to the customer. So that's the typical one scope, and it can go between 3 months to 6 months. The fastest is if you are completely comfortable with the quality of your data. There's typically in these implementations, and you're probably aware of it, but we always have to talk about it. It's about how comfortable you are in terms of connecting your source systems to IBP, being able to validate the data, making sure that the integrations are working and so forth. But it's mostly about how comfortable you are with the master data that comes in and the transactional data. But I've seen one case of a customer that implemented this type of scope in 3 months, but the typical will take between 3 and 6 months. In terms of benefits accruing, I will say that you need to go through maybe 3 cycles of planning using the tool. So once you achieve your business go live, it will take a time for planners to start making decisions with the tool. Planner adoption is key. So as part of the implementation, it's really important to include the training and the change management aspects of it. Of course, people like Westernacher, like us, will help you in that. We'll help you on redefining those processes, training as we go along in implementation, support the change management required to do this. So once you go on a go live, I will say it takes about at least 3 planning cycles, which are typically monthly, to start seeing results, to start building up some of those results. I would say that in 6 months, you will completely see the benefits, right? And then I will say that, after that, you can start then increasing the scope, right? And increasing the scope could be more product categories, or maybe extending to your raw material planning as well, to your work in process planning. So it could go more increasing the scope of your distribution networks, or connecting to your upstream processes all the way to your raw material, right? Yep.
So
I want to keep that answer brief for now.
Yeah,
I could extend forever,
I mean, certainly there's a business case and quite quick return on investment.
Yep, correct.
Good. Okay, we've received another question. Thanks for the session. Do you apply any AI capability in IBP solution scope? And if yes, in which business use case specifically?
So there are three AIs basically already embedded in there. One is the supply lead time algorithm. It includes let's say calculations, statistical. Remember, these are non-stochastic models. So supply lead time, there is a topic there of predicting that's lead time into the future. So there is AI capability there. The inventory optimization algorithm is a non-stochastic model. So there is already AI embedded there. The service level protection is also another one where you can have some, again, these are, we call it AI, but these are in a way machine learning techniques there. So there are three elements: the supply lead time, the inventory optimization itself, the service level protection. There is another AI capability in the segmentation application. So when I show you very simple, again, I try to keep it really high level. We can get very technical here. But when you run your segmentations, there are many segmentation methodologies in the application, but one of them is DB scan, which is a machine learning technique. It's a cluster technique. That is also considered AI machine learning technique as well. So there are embedded machine learning, AI machine learning techniques there, of course, in the algorithms. So the nice thing about it is that now that everybody's talking about AI and machine learning, this solution has been embedding those techniques and those models into the solution. Of course, it's not as flashy as ChatGPT because these are language models. We're talking about optimization, calculations, averages, clustering, all the number-based machine learning techniques.
Cool. Any other questions from the audience? I'm not seeing anything yet. Please post if anything. Now, once we have a true expert online, use the opportunity. But if no more, happy to close on time. And of course, if any questions or advisory needed, please connect me or Alexis directly. You will see the contact details in the presentation deck for sure. Yes.
Thank you so much for your time today. Appreciate it.
Thank you. It was fun and hopefully useful for the audience.
Many thanks, Alexis and Aki, for the comprehensive presentation, and thank you also for everybody attending today. And like Aki said, feel free to contact for more discussion on matter of this topic. There actually is a question or a comment still.
Wow. Last minute or second even.
Yes. Thanks and wishes for more deep dive sessions in the future. Remember that Aki mentioned that there is already some of the topic on the Westernacher website available, and we're also having together with FINUG in June the one session that it's upcoming soon.
Yes, just let us know which sort of deep dive you would like to get. We'll arrange that. Happy to do that.
In our Westernacher website, I've been writing blogs on service level prediction, I recently posted one on supply lead time. So next week I'm going to be part with my colleague Vittorio Cotroni. We're going to talk about why move from APO to IBP. So there is a lot of content in our Westernacher supply chain site where you can look a little deeper. And like Aki say, let us know where you want to go deep dive, and happy to help.
Great. Thank you everybody for the session, and hope to see you also in upcoming FINUG events and webinars. And I wish you a very, very sunny afternoon. Thank you everybody.
Thank you.
Bye-bye.
Goodbye.
Have a good day.